to my channel Kuluru Vineeth. So today I'll continue the arrays playlist. So today's question is, given a input array consisting of negative and positive elements, we should rearrange positive and negative elements such that they'll be next to each other, like alternate positions. So let me take an example and explain this. So assuming our given input array is -1 comma -2 comma -3 comma 4 comma 5 comma 6, so we should arrange in such a way that positive negative numbers are in the alternative positions. Okay, like this: -1 4, -3 5, -2 6, something negative positive negative positive positive negative, such like that. So the question is clear, right? Now coming down to the intuition or approach, what I think what I'm thinking is, first I will sort the given input array and then take a 2 pointers, one pointing to the beginning of the array and other pointing to the end of the array, and for each even and odd indices keep pushing into the new array or original array. Okay, so let me write down that approach. Approach 1, sort array and use 2 pointers. Okay, so let me name this as the approach 1, and input would be integers array, and I will return integers array as well. So first, as I said, we will sort the array. Okay, so let me take that as a sorted array, and then I will take new array to store the resultant array. Okay, so that is int array, and the size would be of the given input array size. And now we will take 2 pointers, one pointing to the left of the array, another pointing to the right side of the array. Okay, and now let's loop the given matrix. Okay, until array dot size, here simple if k modulus 2 is equals to 0. So that is, if it's 7, then I will push result of k equals to sorted of I, and then I will increment I here. Okay, and else if it's an odd index, I will push element from the right side of the array. Okay, that is result of k is equals to sorted of j and decrement j, and at the end of this traversal we will have the required answer. That is, the result would be of such that negative and positive numbers are adjacent, alternatively arranged. Okay, so this is the approach 1. Now talking about the time and space complexity. Complexity where I'm using extra array, so it will be order of n. And coming down to the time complexity, since we're sorting arrays, the maximum time complexity would be order of n log n. So that is the time. So I will write order of n log n, and space is order of n. Okay, so this is the approach 1. Well, is there any other way that we could achieve the same result? Well, there is a way: linear iterating. Okay, so let me write down and explain parallelly so that it will be clear. That is approach 2. Okay, let me name that as approach 2, and input remains same, output return type also remains same. So here we will take again 2 indices. Okay, and other indices is, let me take 0 until array dot size. So here what I'll do is, like, if the element we are at is less than 0, I will increment the above I pointer and then swap the j and ith elements. Okay, like this. That is array of I equals to array of j, and array of j is equals to temp. Okay, so the main motive of this is keep first segregate the negative and positive elements. That is, keep all negative elements to the beginning of the array and positive elements to the end of the array. Okay, then once we got that in the given input array, now what we'll do is we'll take one extra pointer and then write a loop such that until this k is less than size of the array and also I is less than the array dot size. Now what we'll do is we will take one temporary variable and store, and here we will swap the kth and the ith elements. So I will be now the pointing to the first of the positive number, and k will be at the first index of the array, that is the negative elements. So now what we'll do is we will just swap array of I plus 1 and array of I plus 1 would be 10. Okay, and now increment the k by 2 times, that is increment k by 2 and increment I by 1. Okay, so at the end the this array would be having the required answer. So the approach to is nothing but segregate positive and negative elements first, and then use the odd and even concept to get the result. Okay, that is segregate negative and positive elements and use odd and even concept. Okay, now thinking about the time and space complexity, since we are traversing the array only once, so it will be order of n, and coming down to the time space complexity, we are not using any extra array or anything, just the temporary variable, so it will be of constant space, order of 1. Okay, so time is order of n and space is order of 1. Well, okay, so these are the two approaches for this question, that is rearranging negative and positive elements. Well, now let's me write the main function and execute both of the functions and see what their output looks like. Okay, fine. So first let me create the object of the above class, that is rearrange positive and negative, and now print the approach 1 and approach 2. So let me call first approach 1 function, that is int array of -1 -2 -3 4 5 6, something like this, and then write a loop to print the approach 1 answer, that is, and do the same for approach 2 as well. So I'll take this, copy it and do, except that we change the names to approach 2. Okay, so now let's execute and see if they are alternatively arranged or not. One second, let me print here line. Okay, so okay, seeing the output of approach 1, negative and positive elements are alternatively arranged, and approach 2, as well, they are alternatively arranged. So we have achieved our required answer. Yeah, so this is it for this video. Thank you so much for your love and support. Keep watching my channel. There'll be a lot more exciting content coming up your way. Thank you.